Welcome back everyone. Today we are going to discuss about a Python module called multithreading. Multithreading is a technique in programming where multiple threads can be executed concurrently in order to make your program or app way faster than it is previously. So let's see a standard definition what multithreading is, and then let's go through some examples. So first let's understand the concept of multithreading. Multithreading is a technique in programming where multiple threads are employed by a process to execute tasks concurrently. So what are these jargon words, these threads, process? Let's see what is this process and threads exactly mean. So what are the process? A process is an independent program in execution with its own memory space. Processes do not share memory. Good. Okay. Ideal for tasks that require isolation, such as running different applications. Good. Okay. I'll explain about this process and threads once I read the definitions, okay? Don't worry. Now the threads. What are threads? A thread is the smallest unit of execution within a process. Remember, a thread is the smallest unit of execution within a process. Cool? Multiple threads within the same process share the same memory space. Good. Ideal for tasks that require shared memory or data. Perfect. Okay. Now let's understand this multi-threading process and threads with an example. Uh, let's say this is my memory, and at one place I am running Microsoft Word, Microsoft Word, and at some other place I am running Paint. Okay, cool. Now this is the entire memory, and I am running two processes inside it. One process is Microsoft Word, and the another process is Paint. So these two are two processes independent of each other. They do not share the same memory. Like if the Paint is here, I can say Microsoft Word and Paint share the same memory over in this process, but that's not happening here, right? Paint and Microsoft Word is isolated. They are they are running on different applications, so they are different process. They do not share the same memory. So these are the process that are running, or the applications you can say. Now, what are threads? As you can see here, thread is the smallest unit of execution within a process. Cool. So a process is a combination of threads. Yes, you can say that. Uh, Now let's take an example of Microsoft Word. Suppose if I want to type something, if I want to type something A, B, C in Microsoft Word, I'll type it. Then the Microsoft Word will have to check the spellings and punctuations of whatever I have written, and next it has to indent my code. It has to format my code according to the rules and specifications according in that Microsoft Word. So what it does, let's say if there is no multi-threading, what would have happened? I have written my text whatever I want in Microsoft Word. Then the Microsoft Word checks for any errors or syntactical errors or spellings, mistakes, punctuations and all. Then it formats my text and whatever it is. And after that, I can write the another text that I want to, or the word that I want to enter in the Microsoft Word. Until this process is completed, I can't go on and write the next word if there is no multi-threading concept in here. So you may ask how the multi-threading is being executed here. Good question. Now let's see. I'm writing a text in Microsoft Word, and concurrently a thread is checking for any errors punctuation errors, syntax errors, spelling mistakes, and any others. And also concurrently, it also formatting my code. Cool. So over here, for writing, let's say taking 2 seconds, and checking for errors and spelling mistake, say 2 seconds, and then for indentation 2 seconds. Let's suppose 2 seconds. Actually, it takes very minute amount of time. Let's say 2 seconds. So in a holistic view, it takes about 6 seconds in order for me to enter the next word or whatever it is. Alright. Now in the concept of multi-threading, as you can see, this take 2 seconds and the checking of errors 2 seconds and indentation is 2 seconds. So on a holistic view, since all these are running concurrently, overall it takes 2 seconds and I don't have to wait and I don't have to wait until these two processes are finished so that I can write something again. I can write on and it can keep checking. So that's how this multi-threading executes. So I hope you have understood the difference between a process and a threading and a multi-threading. A process is a bigger one and a thread is a smallest unit in this particular process. The threads helps this process in order to execute fast and efficiently. Cool. Now let me erase all this. Alright. That's all about multi-threading, process and threads. Now what are some examples of this? Now coming to the applications, a multi-threading has various applications like you can utilize it in web servers to handle multiple requests concurrently and efficiently, and you can also run some background tasks while you interact the front end with the user. You can run background tasks concurrently while interacting with the user through front end. And next you can do parallel computing too. So these are some various applications. There are plethora of them. You can Google them and see what are the applications by yourself. And next, why to use multi-threading? Good question. The first thing is efficiency. Since it is a parallel execution or concurrent execution, multiple threads will run concurrently or the functions run concurrently. So they save time and they are fast. Hence, they are efficient and they are capable of resource sharing. As I said, this is a process and there are multiple threads within this. They share the same memory. Also, I can say they share the same resource. Cool. Next, improved performance. Since multiple threads are running concurrently, they utilize the CPU at its maximums. They utilize the CPU at its maximum performance. So CPU don't sit idle. So this is why you can use multi-threading. The reasons why you should use multi-threading. Now let's understand the concept of threading more deeply by an example. Here's an example, and I have also made a thread.py file. So let me explain this particular piece of code to you. So here I have imported the time module and I have a function called func over here, and at line number 6 I have a variable s which stores the time that this function starts. I mean before this function starts, and after the time starts, we'll execute the function func, in which there's a method called time.sleep. So this function runs for 2 seconds because of the sleep method, which waits for 2 seconds until the function execution is finished. So this execution takes 2 seconds, roughly 2 seconds. And next, the ending time. This is the start time of the function before the function starts actually, and this is the end time of the function after the execution of the function has completed. We'll note the end time, and after that we'll print the total time, that is the end time minus start time, the amount of time that the function took in order to execute. So as per the code, this function should take roughly 2 seconds. Since this particular line of codes will execute some milliseconds, the overall time taken by this function only, cause it remains silent for 2 seconds or it executes for 2 seconds. So let's try to execute this. Save the file. Let me bring this up. Python thread.py. As you can see, the total time is 2 seconds approximately. Let me execute it one more time. So how much time does this program takes totally to finish? 2 seconds for this function execution and 2 seconds for this function execution, right? Then that would be 4 seconds. Let's see. Yeah, as you can see, it took almost 4 seconds. Now what if I want to execute it 4 times? This would take 8 seconds. Let's see this too. 1, 2, 3, 4, 5, 6, 7, 8, and there you go. It took 8 seconds, 2 seconds for each function. Each function called 2 seconds due to time dot sleep of 2 seconds. Okay. Now what if I want to run all these functions concurrently, so that the execution of these 4 function call will take minimal amount of time, so that my application will be more interactive and more efficient, so that the user's time won't be wasted, as I have explained in the Microsoft Word example previously. So in order to run this concurrently, we should use threading. And in order to do that, we have to import a core module of Python called import threading. And in order to create threads, you have to use the thread method inside this threading module. Threading dot thread. And over here, we have to pass 2 arguments. Second one is optional if you have any arguments at all. The first argument is the target you want to run. So the target in the sense means the function you want to run. In this case, the target is func. Since I am not taking any arguments over here or parameters, I am not taking any arguments or parameters over here in this function, so I am not gonna pass anything. If you have to pass any arguments or functions or parameters, okay, we can just specify args is equal to, and you can list your parameters over here. Suppose I can say SSL, a name parameter. If I am taking a parameter name here, I can pass the name here. Alright, the form of tuple. Remember, this is not a tuple. This is a string. This is a string, not a tuple. In order to make it a tuple, we have to use the comma. Alright, now it is tuple. Cool. Since I'm not gonna take any arguments here, I'm not gonna send it to. So you created a thread T1 using threading module and the method in it called thread with capital T, and you have passed a target called function, the function. Now you have to start this thread. To start this thread, you can use the start method t1 dot start, and that starts your thread. I mean that executes your function. Let's do this similarly to other ones. Let's do this 4 times like we did with the normal calls t2, t3, t4, and in all these things the target is same, the function in which the sleep method is activated for 2 seconds, and now we have to start these functions or threads. t2 dot start, t3 dot start, t4 dot start. All right, now at the end of this we have to use t1 dot join, t2 dot join, t3 dot join, t4 dot join. Don't worry what is this join method, I'll explain it later. As for now, just let's understand this code. A function, and I have started the counter, created 4 threads and started 4 threads and used the join method on these 4 threads, and the counter is stopped, and finally I'm printing the total time the execution of these 4 threads of functions to execute. Python thread.py. So as you can see, all these 4 threads or the 4 function calls took only 2 seconds. What does that mean? These 4 function call ran concurrently. That means all of these ran concurrently. This is T1, this is T2, T3, T4. All of these took only 2 seconds. Whereas previously the function call took 2 seconds, and the second function call took 2 seconds, and the third function call took 2 seconds, and the fourth function call also took 2 seconds. So overall they took 8 seconds, but over here since we were running it concurrently or parallelly, it took almost 2 seconds as you can see over here, and previously it took 8 seconds without threading. So that's the use of this threading module. Let me erase this. Now let's understand this join method. So let me erase all this. I just want a single thread and not this thing too. For in range 6. I want to print 0 to 5 using a for loop in this particular function called func. So over here I modified the function with a for loop which prints from 0 to 5, and the remaining code is same with just a single thread. This is to understand the join method. Okay, now let's execute this. As you can see, the counter is started, then we have created the thread, then the thread is called, I mean the function is called, and after the call it will print from 0 to 5 as you can see here, and after that the end counter will be terminated, and at last we'll calculate and print the end counter. Cool. So this is how, if the join method is there, this is how it works. Now let's comment this and try to execute it once again. Oh, what is this? As you can see, previously we have used the join method over here, and it printed from 0 to 5, and at last it printed the total time. Now without the join method, it printed 0, then the total time, then the remaining ice or whatever it is. What happened? Okay, let's understand this. Let me write this down. So first we have imported the time module, then the threading module, then this function will be skipped since we haven't called it yet. Then the start time will be started, and next the counter will be started, and next the thread will be created. Thread will be created. This is the thread, and this is the main execution flow. Cool. Now the thread is started. The thread is started, which means the function is called. After the function call, 0 will be printed. Cool. 0 will be printed, and and uh, and the main thing is the thread runs in background without the join method. All right. Now the 0 will be printed, as you can see here, and the thread is started here. The main execution is thread is started, and the side thread will be run concurrently in the background. So thread started, and next the end the counter will be stopped, and next we'll print. Over here we have calculated the start time, and over here we calculated the end time, and now we print the end time minus start time. So after 0 printed, we'll calculate the end time minus start time and print it. And after this, the thread will print from 1 to 5. Without the join method, the main execution flow has ran on its own, and it's terminated before the thread can complete the execution. So here the thread executed and printed 3, 4, and so on. So now let's understand what if we have the join method. I have uncommented the join method. Now if I execute this, I will get the same output as here. First the 0 to 5 will be printed, then the total time will be printed. Let's see the execution of this thing. Let's understand the diagram. First the time module will be imported, next the threading module will be imported, and this function here will be skipped since we have not yet called this. So the counter will be started here, start time, and next we have created a thread apart from the main thread that we have, the main execution flow, that means. And next line number 11 we have started the thread. We have started the thread at line number 11, that means the function will be called. And next we use the thread.join or t1.join. That means the main execution flow will stop or wait for the thread to complete. That means the main execution flow will stop at line number 13 until and unless this thread execution is completed. The T1 execution or the function is totally executed, and after the execution we'll go into line number 11. So at line number 13 the main execution flow is stopped until the thread is finished its job. So what's the job of the thread? To print from 0 to 5, right? So it printed from 0 to 5, and after that the end time is calculated. End time is calculated, and we have printed the end time minus start time. So basically the join method is used to stop the execution flow of the main thread, that is the main execution flow, until and unless the threads are finished. So basically the main execution flow will stop until the threads are finished execution. Cool. So that's how the join method works. Without the join method, the main execution will quit on its own. Next, what do we have here? We have finished the join method and the daemon threads. So what are these daemon threads? Daemon threads are those threads that will exit the execution flow when the main execution flow or the main thread or the non-daemon threads have finished their execution. So previously what we saw, with the join method, the main execution flow will stop over here until and unless the thread completes its execution. Cool. Now I want to make the thread quit over here. All the threads quit or abandon the execution when the main execution flow or the non-daemon threads execution flow is over, so that I don't need to run any background task beyond this point where the main execution flow is completed. So that's how we use the daemon threads. If you want to don't run any background tasks after the main execution flow, we can use the daemon threads. All you have to do is you have to set the daemon property to true. T1 dot daemon is equal to true. That's it. And now how this works, let's see. What did I say? Whenever the main execution flow is completed, the threads will be terminated over that point and they won't run any more background tasks. So since I used the join method here, the main execution flow will stop until this thread is finished. So I don't want that. Now let's say I have commented this the join method, I'm not using this. Now what happens? The main execution flow will be terminated. The main execution flow will be terminated. Even so, the thread will be continued. I don't want this particular thing. I want the thread to be terminated where the main execution flow is completed. I don't want to run beyond this point or execute this beyond point. So in this case, we will use the daemon threads. To make a daemon thread, you have to set the daemon property to true. So now let's see the output. As you can see, 0 is printed and the total time is calculated and the main program is terminated. So that's how we use daemon threads. And the difference between the daemon thread or normal thread is that the normal threads use the join method and the join method is used to stop the main execution flow until and unless the subthreads or subprocess complete their execution. It waits for the subthreads to complete their execution, whereas the daemon threads will be terminated when the main program flow is terminated. They don't run beyond that point. When the main thread is terminated, they should have terminated too. So that's all about this threading, guys. I hope you have understood this threading module and the difference between process threads and why these processor are isolated and they do not share memory. Threads or smallest unit of process, they do share memory and they can be run concurrently. And the example and the applications, like you can use it web servers, parallel computing, etc, etc. There are plethora of things. And then the advantages of this, and in a example, with and without join, the daemon threads versus normal threads. So that's all for this tutorial, guys. I hope you understand the concept of this multi-threading with how you can execute this multi-threading in Python. If you have understand the concept, you can share, like and subscribe the channel so that I can get motivation and I'll do more and more videos like this. Thank you.
मेरा ये चैनल सब्सक्राइब करें और मेरे हर अपडेट आपको मिले, इसके लिए बेल आइकन जरूर दबाइएगा। आप सभी को मेरी ढेर सारी शुभकामनाएं।